Our next session of the day is turning up the heat pumps on hot water. I'd like to invite the panelists to come on up to the stage. Come on up. Our moderator for this session is Bomee Jung, co-founder and CEO of Cadence OneFive, and you can find all of the bios of all of our speakers in your program.
All right. Thank you so much for having me. Wow, look at this full room. So what I'm going to do is I'm going to do a very, very, very short scene setting, and then I'm going to introduce our speakers, and then we're going to go right into a Q&A panel discussion. So just as an intro, again, I'm Bomee Jung, co-founder and CEO of Cadence OneFive. Probably a lot of you know me more in my prior roles as having run the energy sustainability construction program at NYC. What we do now at Cadence OneFive is develop software to speed up the pace of multifamily decarbonization. We have customers here in New York. We're 3 years old, but we're just about to start going national. So one of the things that we actually do, and carrying over from work that we've done that in the past is sort of participate in research programs. And so one of the things that we've done recently is working with Nicole at Stephen Associates, really looked at the drivers behind heat pump adoption. And so just to set the scene here, and just to level set for everybody. So what are we talking about when we talk about the DHW heat pumps? Well, first of all, obviously a heat pump is a machine that moves heat from one place to another, sort of like your refrigerator. And then just to sort of lay out a quick typology, we can talk about where is that heat coming from. So is it an air source heat pump moving heat from the air, water source or ground source? And then we can talk about, well, the actual technology itself. Is it developed to work in cold climates like New York? Is it a split system where the condensing piece of it sits outdoors and then you've got the thing that heats the water on the inside? Or is it one piece where it takes the heat from for example, in the air source heat pump, that's integral. It would take the heat from inside of the machine room that the heater is sitting in. Does it produce high temperature hot water? Does it produce mid temperature hot water? Is it meant for decentralized hot water systems, like you have a system in each apartment, for example, or is it a centralized system like we have in most apartments? So these are sort of the equipment considerations. And then there's the deployment. How are you going to deploy the system? So is it a system that is going to carry all of your DHW load, or is it going to be installed in a multifamily context or a single family context? Are you putting it in a retrofit situation or a new construction situation? So this is sort of the set of questions that we deal with, that we're going to deal with here in various ways on the panel. And so having said that, well, why are we talking about domestic hot water heat pumps? So first of all, domestic hot water is a primary use of energy in residential buildings. It counts about 20% of the greenhouse gas emissions related to housing. And obviously, we talked a lot, I'm sure everybody in this room talks a lot about heating system, electrification, but if you don't get the hot water off of the gas grid, then you don't get to do anything about that gas grid, right? Like we're going to have the situation where the users who are using the gas grid are now paying for all of the infrastructure costs of the gas grid. So it's a different kind of, different variation on that same story of the folks who electrify get to opt out, and then everybody else is paying for the infrastructure that remains. And so this is sort of why we're talking about hot water. And ironically, if you all throw your minds back a few years, right, we all thought that DHW was going to be like the easier thing to do, the thing that we were going to all do first because you didn't have to go into all those apartments. And it turns out to be hard. Surprise, surprise. Not like, why would something be hard in construction? I don't know. All right, so with that, I want to introduce our speakers. First of all, here to my left is Jen Leone. Jen is a sustainability expert who's been specialized in working with affordable housing buildings. In her role as Assistant Commissioner and Chief Sustainability Officer at HPD, she oversees a lot of pilot programs. She does a lot of stuff, but among them, she oversees a lot of the pilot programs that helps to push our field forward in adopting new technology, including pilot programs around electrification. And then to her left is Sara. Sara is an architect specializing in, sorry, I was like, what is this? Specializing in sustainable design for both new construction and retrofits. Her work navigating the requirements and the incentives you require for electrification in new buildings, as well as retrofits, is going to provide us perspective on what it's like from from the design implications and strategies that she's seeing on the ground today. And then to her left is Nicole. Nicole is an engineer, and she's been working on heat pumps for domestic hot water for almost a decade at this point. And she brings, the technical expertise on what the available systems are, what the retrofit approaches are that she's seen on the ground, and sort of outlook for new products and package solutions that overcome some of the barriers that we're looking at right now. So with that, I am going to go right into my opening questions. So the first one is for Jen. Jen, can you share your perspective on how the electrification of domestic hot water fits into the bigger picture of what you're trying to lead with the city's sustainability program for housing?
Started. Now is that working?
Oh, yes.
Great. Okay, so what I can talk about really is the world that I oversee, which is regulated affordable housing, specifically in New York City. So all of the projects that are receiving HPD funding to do new construction and preservation. And of course, the elephant that's in the room is Local Law 97. And again, Bomee said it right off the bat. We thought that DHW was going to be the easy lift for, complying with Local Law 97. It was going to be simpler. It was a good stepping stone. Since the law passed, we've been actively, as an agency, trying to figure out how to electrify strategically. We do a lot of buildings, a lot of dwelling units in the city. And we thought that it would make the most sense really to focus on the most polluting buildings that were in the most trouble. And because we write design guidelines for the work that we do, and we have pilot programs to fund them, we're really focusing primarily right now on buildings that are on oil, right? We need to get buildings off oil. They're the best use cases. They make the most sense. And even where DHW is hard to electrify, it almost always needs to happen on those buildings. And our other priority area are buildings that are in flood zones and have other reasons that really need to get off, the system that they're in for resiliency and decarbonization. And we think that the next frontier is, once we learn all the lessons and figure out how to do it, we can really start moving this technology into buildings that are on gas, which in our world, where we have limited amount of money, we're not focusing at the moment.
Thanks, Jen. So Sara, for you, I want to start with what's relatively easy right now. So for you, so MAP is doing a lot of cutting edge new construction projects. Can you walk us through how domestic hot water systems are designed in the conventional new construction versus what you're doing now in your electrification projects?
Sure. So when we were more in the recent past doing gas-fired condensing hot water boilers, most of the equipment is on the roof, and it still is. In our current new construction buildings are all electric, and we need a large water tank room on the roof. It's still accidentally called the boiler room, but it's the tank room now. And yes, we're doing retrofit as well with buildings that are currently on oil. And most of our new construction buildings are doing air source for hot water, but we're also looking at water source with ground source heat pumps, and also waste heat recovery with all that heat we're wasting.
Lots of fun stuff.
Yeah.
Great. So, and Nicole, so you, again, as I was saying in the intro, you've been working on domestic DHW heat pumps for probably longer than anybody else. Can you give us sort of like a high-level overview of how that market and the technology has evolved over time, and where we are today in terms of what's needed in our buildings?
Sure. So I did my first heat pump water heater project about 15 years ago. And that was working with integrated tank style heat pump water heaters like you see in a single family home. At that time, there were some pretty good options on the market for those. It was in a smaller building stock where you could get away with using that equipment. So yeah, that was about 15 years ago for me personally. There are other folks who were doing that work long before then. I would say roughly 10 years ago, we started looking into the kind of commercial grade version of that equipment, the split systems. How do we harvest heat outside, bring it indoors to meet our hot water loads in our bigger buildings? And at that time, there were maybe 1 or 2 products available on the market, and like maybe available, maybe not, kind of depends on who you talk to. And I am talking about our market here in New York, cold climate products that work here. I work with folks on the West Coast in California, more mild climate. They've had better options for a long time. So yeah, 10 years ago, we were trying to figure out, like, can we get a heat pump here and do something with it? I would say about 5 years ago, that's when the tables turned a little bit and it stopped feeling like I was going out trying to find solutions. And all of a sudden, I started getting these like breathless messages from reps like, we're bringing a heat pump. Check out our heat pump offering. And all of a sudden, it felt like more and more companies were launching something. And like the quality of that something in terms of how it fits in our market or what kind of application support there was varied widely. Some of them are like great additions to the market that I'm still using today. Some of them I don't think really fit in this market. Some of them have kind of quietly disappeared. It's, all over the map. But it felt like that was kind of a turning point. And, these things, they start exponentially taking off. And I would say in the last like 2 years maybe, we're seeing a bigger move towards integrated, holistic approaches to water heating with these products. So it's not just, hey, look at our heat pump anymore, but we're starting to see more manufacturers and their reps bringing a full plant design and offering to the market. We're starting to see really, really, really smart applications engineers at manufacturers, at reps. Some of the startup technicians that I've worked with in the field just know like every detail of how the whole water heating ecosystem works. And so we're starting to see kind of a more integrated approach taking off. And we're starting to see more good products and more good products like applications approaches coming to market kind of now and looking into the near-term future.
Yeah, thanks. So, just as an extension of that, I would love to just do a quick status check in the room. Like, can you raise your hand if you're working on a project that has a heat pump DHW incorporated in it? Look at that. That's quite a few. Can you keep your hand up if it's a retrofit application? Wow, look at that. That's pretty encouraging to me. I think that's amazing. So, Nicole, back to you. So, in terms of the projects that you're seeing right now, what are some of the challenges that folks are running into, and where does it make the most sense right this minute?
Sure. So the number one challenge that I run into is getting a project to happen, and that like major breakage in the project pipeline, at least in my experience, is economics. So that's the number one hurdle. These are expensive projects. A lot of times they don't result in any energy cost savings or so little that you can never justify it on payback alone. So yeah, economics are the biggest hurdle that we're seeing right now. What was the second part of your question?
What is for a project that pencils out and works today? Mm-hmm. What does it have to have for it to pencil right now?
Yeah, I've kind of, I would say 5-10 years ago, I was hyper fixated on like, can we find the best technical candidate for this work? What minute detail of a building's layout, its architecture, its siting, its equipment, its systems, what all those little details, can we like score them and come up with a score to find like the best technical candidates for a heat pump? And then like none of those projects happened. So it sort of showed us that we have to kind of focus on the non-technical pieces of it, which like I'm an engineer's engineer. I'm not good at the non-technical pieces of a project development. But we've had to take this much more holistic approach to understanding what are the client's goals? Why are they even interested in this in the first place? What pain points do they have? What are they trying to solve in any project they do? What kind of funding can they get a hold of and what strings are attached to that? So we've had to start thinking much more broadly about these projects.
And Sara, for you, how has changing over to using electrified hot water as your sort of main, as the thing that you're now doing day in, day out, like how has that changed your like architectural design considerations? Or how's it changed the way that you work generally?
Yeah, maybe not as much as you might think, but we're again using the roof, and the space that we need is it's much larger than we used to, and if you have 33% of your roof covered with mechanicals, you need on a high rise, you need to make that a story, so you need to bring an elevator up, and you kind of need to plan for these really large tanks because heat pump hot water doesn't make the hot water very fast, so you need a lot of storage, as most of you probably know. So that extra weight and that extra size of the tanks, and just kind of guiding your clients towards thinking long-term about owning that equipment and, making larger doors and pathways to service them. And actually that elevator to the roof could be quite handy in the future, and we've seen that happen. But it's really, more recently, 7 years ago when we were designing our first electrified all-electric building, there weren't a lot of manufacturers, and now there are a lot more, and we're seeing a lot of change in what's available. So we're going to keep innovating, I hope.
So in those projects, what do you get excited about?
Well, I always ask, are we saving carbon? Are we saving energy? I think, I like the opportunity of not having a gas connection, especially for a renovation project that has a big oil tank, for example, and has some gas for cooking. It might not have a room that's designated and fire rated. Anyway, there are a lot of spatial implications to these decisions, and you can use them to your advantage, not having that gas connection, if you don't have a generator, because we still don't know how to solve that one yet. So.
Jen, are you busy these days? You got a lot going on? No, not at all, right? You don't have anything going on at all. So housing is having kind of I think it's going through a little bit of affordable housing is going through a little bit of a difficult moment with a lot of different things coming at it, right? So you have the cost of insurance, you've got the long tail of COVID on rent collection still, probably landing somewhere. You got the cost of non-energy requirements, compliance like FISP still hitting folks. Given all of these things that are happening in your constituency, where is DHW electrification on the list, on your list of priorities?
All right. Do I have this on or do I turn it off? Okay. I get the, heat pump technology way better than microphones still. On our list of priorities, one thing I forgot to mention when I was talking earlier is, we already require all electric new construction as of last year for all of our projects. And for us, that was a really important priority because these buildings are built for a really long time, and we do not want to see them come back to us and, when local law 97 changes or something else and say, oh, we're still on gas. We have a gas hookup, we have gas hot water, now we have to fix that. And what's really exciting, which wasn't really the question, but what's really exciting to see is the innovation happening in new construction where there's space for it. And I don't know how many people here who raise their hand for DHW are doing it on an HPD project, but feel free to raise your hand. Not a lot. So maybe you're not familiar with this, but we get a lot of the most creative and leading edge design teams working on our projects. So we're seeing all the innovation that Sara's team and the other teams are doing across the full electrification spectrum. So we're starting to see heat recovery and so on. And we want that to happen. It's really important for us, especially to test all of this technology where it's easiest. And you might say new construction, hot water electrification, still not easy, but it's easier than on retrofits. You know, there's space and you can design your structural systems to accommodate it. And then, you know, the other places we're seeing a lot of action is through these pilots because there's funding for it, right? And once you start to introduce the requirements and the funding together, people look and they say, you know, I'm going to try and do it. I'm going to go for it. I didn't think I was necessarily going to go this direction. So I think that's what I would say to answer that. Did I miss anything in the question?
No, but I have a follow-up.
Yeah, please.
So you mentioned, you know, the pilot programs that you're running. What are the levers that are available to you to push adoption of heat pump DHW that you're excited about?
Well, our requirements push it because we require it. So again, I don't know how exciting that is to make everybody do it, but it's certainly making it happen. But we are, you know, our retrofit electrification pilot, we're on, I think, year 3 of that, and it's all NYSERDA funded. And that is an important lever. We are able to bring people in. We have a technical assistance provider team for our projects. So these are teams that are coming in and they're retrofitting everything from like a 9-unit affordable housing building in the Bronx, right? Maybe a co-op, maybe not. They really have very limited capacity to get this done, and we have the team and the money to help the designer, the architect, and the building owners understand whether they want it and how to make it happen. And also because we're trying to design the whole ecosystem for affordable housing, we created utility allowances and electric heating and hot water maintenance and operation standards for our buildings, right? So when you're looking and thinking, can I really do electrification of anything but hot water heating in this case, I can look and kind of understand right up front, you know, will it fit in the budget? What is HPD telling me that it's going to cost to operate? And we think that's really important to have some, you know, forward-looking insight on the projects and not have it be a mystery until it's already designed and too late to change the design if it's not going to really cash flow well.
Speaking of things that happen after you design, this is a question. I'm gonna do a little bit of a variation on this question that's coming from the audience for you, Sara and Nicole. So the question is, can you talk about the capacity of the utilities to provide increased electrical service at buildings as they're electrified? Maybe you could also just very, very briefly sum up like the process, either one.
The process of making sure you have enough power in the street is getting a good estimate early, and that might mean energy modeling your whole building early, ideally. And then having your engineer reach out to Con Ed with the appropriate load letter. And sometimes in jurisdictions you have plenty of power, and other times the whole block needs to be upgraded.
Yeah, and I'll say the process, it can look really different depending on what kind of project you're working on. So most of my work is retrofits and like occupied retrofits where we're maybe doing one system at a time, not a gut reno, not even a reno that's touching, you know, heating, cooling, and domestic hot water. I'm working with plenty of clients who they're looking at maybe electrifying their domestic as a discretionary measure that they'll do just to sort of get into electrification a little bit. And for those projects, the pathway we usually take is filing a load letter with Con Ed. We'll do maybe an electric load study. But if we're just looking at domestic hot water, it's usually not quite as big of a deal. We're not as worried about the electric service in a lot of the buildings we work with. We just tend to see those load letters coming back fine.
Do you have any wish list for Con Ed in terms of transparency?
I didn't hear the last word you said, but I heard wish
Transparency, for
list.
transparency.
So, yeah, there are a handful of things that come up. I mean, I said earlier, I think one of the biggest hurdles that we see, one of the biggest sources of breakage that we see in projects getting done is the economic side. And it's one thing to say we've got 5 different incentive programs across the city and state that can incentivize this work. It's another to actually coordinate them all and stack them all successfully. And it can feel like you're playing whack-a-mole. Like I get one project, I get like one incentive secured and squared away, and then I go to file for like the stacking matching incentive cost share from another one, and as I'm getting that one filed, the first one's changed their rules or run out of money, and then I get that second one squared away, and then I'm back to the first one again. And then in that time, that other one has like turned over its application cycle for year 2024, and there's a new set of paperwork that you need to fill out now because we're in a different calendar year. And then I'm back to this one. And it's just like, in reality, it doesn't work. You can't get all of these ducks in a row and get them all like squared away and sitting there for long enough to then go back and work with a client who has very real financial hurdles to work through and a whole, financial stack to figure out. It's too many moving parts. And I think that is a very, very real source of, it's caused multi-year delays on some of my projects personally.
So I think this is another question from the audience. I'm going to take a slight variation. So like so given all of the hurdles, why are folks doing it?
Sure. So I think if I just sort of mentally poll my clients, a lot of them are mission driven. Some of them are thinking about Local Law 97. Some of them are thinking about Local Law 97 and the beneficial electrification credit. I'll plug Urban Green's write-up of that credit, which I thought was really lovely. So some of them are doing it for those kind of financial reasons. Some of them are doing it because just like from a visibility perspective, they don't want to have Local Law 97 fines, even if the cost of fighting, or not fighting, but the cost of avoiding those fines is not actually a financially sound argument for them. They just don't want to have the fines, so they're going to do this work anyway to avoid having any fines. But yeah, some of them are just mission driven and they want to understand how heat pumps work. They want to figure out how to apply them across maybe a bigger portfolio. So they're kind of willing to take a risk or take a loss on 1 or 2 early projects just to figure out how it all works. There's a handful of different reasons.
Great. Sarah, I have 2 questions for you. One is, are you seeing new construction projects that are opting to go with a decentralized system versus a centralized hot water system at all? Is that something that you think is that might become more popular in new construction? And then have a totally separate follow-up question.
Okay. In affordable housing, I don't see decentralized becoming more attractive because it takes up floor area space at the apartment that we use every square foot, and also the cost for the hot water is usually on the owner, so centralized systems makes more sense.
And then the second question is, could you mentioned a project that had waste heat recovery. Can you talk about that project?
Yes. So this space is enormously ripe for innovation. So one building of ours has a large residential apartment tower and then a shelter on the lower floors. And the tower is using air source heat pumps, and both the waste heat from the water from the tower, the residential tower and the shelter is collected in a tank at the bottom level, and then water source heat pumps extract that wasted heat to make hot water for the entire bottom portion of the building. There's an overabundance of waste heat. So you could have, I asked the engineer to kind of give me a percentage, but I'm guessing, she hasn't got back to me yet, but I'm estimating it's about 50% of the residential tower can be occupied, and that's plenty of hot water for the other portion of the building. And this system, they priced out a water source system, a hybrid of air source and water source, and an air source for the shelter portion, and the wastewater costs 30% less, and it has energy savings over time because the COP for that water source remains at a constant 3 or 3.5, and of course the air source is variable depending on the climate. So there's also a ground source project we have using, I'm not sure if we're calling it geothermal or ground source, but either way, we're not in a volcanic zone, but so it's ground source heat pumps, and it's a passive house building, so it's cooling dominated. And with ground source, it's very important to keep your ground balanced. So you really want cooling and heating loads to remain about the same over the year. So being a passive house, it's a perfect candidate to then have add hot water to that load, and it keeps your ground balanced, which both projects have this beautiful synergy going on. Thank you.
Jen, for you, are there, so 2 questions. One is, are there now enough DHW heat pump projects that you have some sense of cost data?
No. It takes a long time for people to design them, and it takes even longer to build them. So we are working with a number of people to start collecting the data on this, but right now we have predominantly modeled savings that we think and hope might be accurate, but not enough to really utilize to set anything in stone.
And all of y'all who raised your hands that you're working on DHW heat pump projects, you're going to email your costs to Jen after this, right? So that everybody can benefit from your knowledge. Okay, the second question, that was sort of a joke, maybe a joke. The second question is, where and how can we get more publicized successful pilots and stories out there? How can we promote the successes more?
It's definitely part of our mandate under our pilot to do and present case studies. And again, we try and do this when we can, but without the data, the case studies aren't terribly useful. We want to see the projects designed, built, and operational before we start sharing success stories.
Thank you. So let's see. I'm not sure how to read this.
Hey, Bomee, while you're reading that, I'm going to jump in for a second on that one, too. When I spoke earlier about the whack-a-mole of stacking incentives, I think getting to a point where we have robust case studies has been extremely difficult. The programs that we have available, they'll incentivize a heat pump, they'll incentivize this piece of equipment. Getting something where we can get enough incentives to cover, to at least take the pain out of putting in the equipment, the heat pump and the new system, plus getting incentives to cover M&V and cover that monitoring equipment, cover that analysis, cover that long-term data hosting, cover that commissioning and recommissioning and replacing of sensors over the year time that you need them in place. We don't tend to have incentive programs that cover all of that. They tend to cover one piece or another piece of it. So we found, and on top of that, our clients tend to not have the funding to go in and put in $10,000, $20,000, $50,000 worth of M&V equipment on top of a several $100,000 heat pump. So yeah, we've just found that it's been very hard to even get the funding to do these case studies, and there seems to be kind of a disconnect and a mismatch in terms of where the market is and where some folks think the market is. I think there's this feeling of well, we have heat pumps that we can buy today, so we're good. we've solved it. But we don't have those case studies, and we don't have the funding to really get enough of those case studies to help seed the market and speed it up a little bit.
I think this is sort of a related question, and I'm just going to read it verbatim. So it says, concessionary capital is incredibly important to improve the economics of a project. Is there any work being done to improve this application process for companies?
The question was, is there any work being done to do what?
To make it easier to get concessionary capital, subsidies.
I can speak to that at least from the standpoint of the housing agencies. It's not just HPD, but also HCR have really well-funded capital. We have grant money coming from NYSERDA that flows into our deals to cover electrification and other high-performance initiatives. That's really limited if you're not doing our projects. There's not much to offer on that. Inflation Reduction Act, we're all hoping that there's going to be some really solid concessionary capital to cover this kind of expense, but nobody really is sure at this point how that's going to pan out, who's going to be able to grab it, how it's going to be accessed, and what you'll have to do to get that money. I wish I had more information, but stay tuned for the NYC panel in October where we'll talk about that.
Okay, so we have a bunch of fun, like relatively short questions. I'm just gonna throw them out and y'all grab them, okay? So one is, how maintenance heavy are heat pumps compared to traditional equipment?
I think I would say I learned my lesson 10 years ago when cogen came on the scene pretty big in New York, and everyone was like, well, you just buy a service plan and they rebuild the engine whenever it needs to be rebuilt, and they replace this at this many hours and this at that many hours, and it can run forever. And that's not what happens. So we don't have enough of these heat pumps in the field. They haven't been running long enough for us to really be able to say, this is what they actually need at 1 year, at 5 years, at 10 years, et cetera, et cetera. I don't think we can answer that question yet. We know what the manufacturers say should be normal. We know what kind of maintenance is recommended. But in reality, like I would not feel comfortable speaking to that until we actually see some of these that have been operating for a while.
I have posed the question to all engineers that we work with, and they are saying this is a more sophisticated equipment than our traditional boilers. But boilers have had, I don't know, 100 years to innovate and fine-tune and figure out. So we're at the kind of beginning, but it's been more beginning for our area. A lot of areas have already had this for a while. And we need prepackaged options. But in terms of, specifically maintenance, we definitely need more training and just more excitement about it.
I might be a little skewed because of my particular experience, but I'm not really sure that traditional boilers get all the care and loving that they need. So I'm not sure what exactly we're losing there yet. So the next question is, have you seen heat pump hot water solutions used for energy storage purposes to get subsidized for energy storage as thermal storage?
Sure, yeah. So if you are applying for clean heat incentives, category 6, custom, you need storage. So if you're taking advantage of that incentive, which I'd be shocked if there's anybody doing this work who's not, you're putting in storage. There hasn't been a ton of work in our market looking at load shifting with that thermal storage. Like we don't have a grid signal coming from Con Ed telling us when to shift. We have, especially in multifamily, we don't have a ton of clients who are on time of day rates or who have building level controls that allow them to do load shifting. That said, we have a DOE project that we're kicking off that is going to have that kind of load shifting testing being a part of the pilots that we're doing. And we're partnering with some folks from the West Coast who have been doing load shifting on like a California grid where you can really monetize that for quite some time. So I think we're starting to bring the load shifting and real use of that thermal storage, like surgical targeted use of that thermal storage, we're starting to bring that to our market. But the examples that we've had in our market so far have been either more like academic research, let's see what it could do, or maybe shorter pilots and tests. I don't think it's really taken off yet.
Sarah, I think this one is for you. Can you explain the generator requirements for heat pumps? Do you need to add a generator per code? Can you do portable generator hookups? I think it's because you mentioned generators earlier.
Yeah. So when you have a high-rise building, you're required to have a generator, and you can do a battery. I'm fairly certain if your battery is large enough, you can do a battery, but the permitting and the ongoing commissioning of that battery are very intensive for our area. So most of the time, it's a gas generator. Does that sort of answer the question?
I can also add, I mean, if you're doing an emergency generator, you've got life safety loads in code that you have to meet, and like what codes you need to meet are predicated on what kind of building you're working in, how tall it is, what kind of occupancy there is, its use case, all of that. And so there are different rules for what you need to have generator backup on and how quickly that generator needs to kick in, how quickly it needs to take on those loads. Yeah, varies depending on kind of building. Usually convenience stuff like hot water isn't going to be required. That's not a life safety. It's just you got a cold shower, I'm sorry. So yeah, usually you're not worrying about those kinds of loads from a life safety perspective.
Jen, I think this one is for you because of a comment you made earlier. So what is the foreseeable timeline for when HPD will be able to focus on buildings with gas?
That's a really good question. I have no great answer for that. I think right now we're trying to make, a not huge amount of money go as far as we can and stretch it and test it and use the money where we think it's most wise. We have funded a couple of projects that were on gas that were electrifying, their heating system if there is some other factors that, that play into the decision making. But would we necessarily want to start fast tracking like gas, hot water to heat pumps? I don't know. We're waiting for the right cases to be made for that to happen and enough money, to be able to put it everywhere that everybody wants to fund. But we're taking a strategic and careful approach right now.
So we have a few questions here that are generally asking about the direction of the technology itself. One of them asks about refrigerants. One of them asks about reusing refrigerants. One of them asks about something about solid state technology. Like, what are the things that y'all are seeing in terms of where the equipment technology itself is going?
Sure. So refrigerant phase-out regulations, everyone's been talking about them quite a bit. They don't have as big of an impact on domestic hot water, but it's got us all talking about it. I think kind of one of the fun things is that one of the best refrigerants for making domestic hot water in a heat pump in our climate is CO2, global warming potential of 1. So regulations aside, there's a really good technical reason to use a very low GWP refrigerant in a cold climate. And we're starting to see a lot of manufacturers, reputable manufacturers, bringing some pretty cool CO2-based heat pump water heaters to this market. They're not all for sale today, but talk to me in a year and you're gonna have several more options than you have today. So yeah, we're seeing a lot trending in that direction. We are also seeing we're also seeing folks experimenting with other technologies. You mentioned solid state. There's a couple startups who are looking at it. We're also seeing some folks start to think a little bit more about phase change materials and other storage media. I think all of that stuff is several more years down the road. Like when I look on the near-term horizon, I am seeing more low GWP refrigerant heat pump water heaters, though.
Yeah, same here. Yeah, CO2, but not all engineers are as excited about CO2 or see it as covering the whole market, but definitely a large chunk for our climate. I did want to mention another thing about resiliency, because you have pipes probably in your roof going from inside to outside. You know, they're well insulated. They usually have heat trace on them. If there ever is a power outage, you might want to put valves, manual valves, to kind of drain those pipes. That's kind of a concern that's come up on a few projects in construction. Actually, the contractors thinking about good questions, which we love when that happens, and that's one of the things we learned.
So another question on a different topic is, what workforce training is needed to make the design and installation process smoother?
Yeah, I think it's a little bit of a moving target. So some of the heat pump manufacturers that are bringing products to market are taking pretty different views on how serviceable those heat pumps should be in the field. So there are some who are saying, we want to have a modular heat pump out there, so if something breaks, you don't have to pull this entire thing out and put an entire new thing in. And so in that case, you know, you've got training requirements for actually doing real work inside the heat pump. If you compare that to a manufacturer who takes a much more packaged approach, then the service requirements in the field become very different. And it's much more about just assessing, is this thing bricked or not? So the requirements do kind of depend on where the manufacturers are going. I think that one of the big issues that we kind of saw with heat pump water heaters coming to the market, is that they did start off as just here is a product, you can buy it off the shelf. Okay, MEP community, figure out how to design a plant with this. And a lot of times, MEP here, there was not enough documentation to do that correctly. So you were trying to design a whole plant around a piece of equipment without knowing 50% of what you need to know to be able to do that successfully and correctly. And so, yes, there was a training need, but there was also kind of a different approach needed from the manufacturers. And then you get into the field, and there's like the installation and operation manuals for these things were also missing 50% of the information that they needed. So yeah, an installer needs training, but they also needed just the tools from the manufacturers to be able to do their jobs correctly anyway. So there were a lot of pieces missing along that chain. And I think all sides have been coming together a little bit better to move towards that model of selling a holistic, pre-configured plant approach, whether it's an actual plant or even just like the knowledge of here's how this piece of equipment fits in with all the accessories and components that it needs. And I think that's going to go a long way towards sort of lowering the burden and not setting everybody else in a project team up for failure. And then I think that kind of clarifies a lot better what are the true training requirements to then get this equipment into the field.
Interesting. So we're running up on time here, so I want to ask one last question. So, we thought this was going to be the relatively easy thing to do. It turned out not to be. So I don't know if you want to pick like your one challenge that you think we can solve to start getting DHW heat pump adoption to move faster, or just in general, what do you think we need to be doing to get that train out of the station? Whoever wants to jump in and start.
We need gas to cost what it really costs.
That might be a mic drop. I don't know. Y'all want to? Other thoughts?
Yeah, I completely agree. The economics are the biggest roadblock, and that needs to change. I also think that we, from just a technical applications perspective, we need to keep working on that whole plant approach. You can come find me in the reception afterwards. I have frozen heat pumps on a rooftop. It doesn't feel good. And why did that happen? Well, we were working off a translated manual that was missing significant information. And, you know, there's only so much that you can do when you don't have all the pieces that you need. But if we move towards this kind of more plant-based approach, tried and true designs, we're not reinventing the wheel on every single rooftop, then we don't need to all learn those painful lessons. We can kind of pick up at square three and just get it done. And so, yes, we need the economics to make sense. We need a spark spread that is viable to get the projects in the door. And then we need that kind of applications ecosystem to get them, I don't know what's passed through the door, but get them to like actual completion and successful startup.
How about you, Jen? Tools of government?
Tools of government. The money thing is real. But the other thing that sort of rolls in all the pieces, and this is one thing that the reason that pilots are so important, is we can start to aggregate all of the lessons learned into our pilot and integrate them into like our pilot technical requirements. So Sara talked about the freeze protection issue. Well, guess what? Somebody alerted us to that, one of our technical providers, 18 months ago. So we now have that in our technical requirements. Our technical requirements filter out to all of our guidelines. And that's the kind of thing, by aggregating all of this work under one entity who's really trying to capture the data and the information, that's where you get all the pieces and best practices rolled together. So you need all of it, but then you need to disseminate it, collect it, and get it out, into the market.
Thank you for that. So thank you so much for the work that you're doing. It was a lot of fun to sit up here talking about these things with you. And I think do we have a break now? Is that what happens? Don't dismiss anybody yet. Oh, please don't go anywhere. Thank you.